sklearn, linear model, LARS path. Description. The least angle regression LARS algorithm finds the solution path for a linear model by progressively adding variables into the model in a greedy fashion. It provides a more efficient way to compute the entire regularization path compared to using the coordinate descent algorithm as in LASSO for a large number of features. Inputs. X. This is the input feature matrix. It should be a 2D array of shape n samples. N features. Y. This is the target variable. A 1D array of shape n samples. Outputs. Copath. A 2D array of shape n features. N steps containing the coefficients of each feature at each step of the LARS path. Intercept path. A 1D array of shape n steps, containing the intercept of the model at each step. Active. A list of lists, where each inner list contains the indices of the active features at each step. Steps. Initialization. Start with an empty model, no features included, and a residual equal to the target variable. Feature selection. Find the feature with the highest correlation with the current residual. This is the feature that would contribute the most to reducing the residual. Step direction. Determine the direction in which to move the coefficient of the selected feature. The direction is either towards its positive or negative correlation with the residual. Step size. Calculate the step size for moving the coefficient along the direction. The step size is chosen so that the coefficient of the selected feature reaches a point where another feature has the same correlation with the residual. Update model. Update the model by adding the selected feature and its corresponding coefficient. Update the residual accordingly. Repeat steps. Continue steps 2 to 5 until all features have been added to the model or the desired number of steps have been reached. Metrics. R² measures the proportion of variance in the dependent variable explained by the independent variables in the model. Mean squared error. MSE measures the average squared difference between the predicted and actual values. Visualization plots. Coefficient path plots the coefficient values of all features against the LARS path steps. This visualization shows how the importance of each feature changes as the model progresses. Residual plot plots the residual values against the fitted values. This can help identify patterns in the data and check for heteroscedasticity. Fine-tune parameters. APES. This parameter controls the tolerance for the convergence of the algorithm. Smaller values of APES result in higher accuracy but may increase the computational cost. Maxiter. This parameter sets the maximum number of iterations to run the LARS algorithm. This can be used to limit the time taken for the algorithm to run. Uncertainty methods. Bootstrap. Generate multiple bootstrap samples of the data and fit the LARS model to each sample. The variability in the coefficient estimates across the bootstrap samples can be used to estimate the uncertainty. Cross-validation. Use cross-validation to evaluate the model performance on unseen data. The variability in the performance across the different folds can be used to assess the uncertainty. Challenges and fixes. Challenge 1. High dimensionality. When the number of features is very large, the LARS algorithm can become computationally expensive. Sample use case. A dataset with millions of features. Fixes to challenge 1. Feature selection. Use feature selection techniques to reduce the number of features before running LARS. Random sampling. Use random sampling to select a smaller subset of features for LARS. Challenge 2. Collinearity. When there is high collinearity among features, the LARS algorithm may be unstable. Sample use case. A dataset with several features that are highly correlated. Fixes to challenge 2. Regularization. Use a regularization technique, such as lasso or ridge, to reduce the impact of collinearity. Principal Component Analysis (PCA). Apply PCA to reduce the dimensionality of the data by transforming the features into a set of uncorrelated components.